Hello 8th graders, this video is for ELR 5.6. In this video we need to talk about the differences between the two different types of bonding that can happen in chemistry. This is the culmination of all of the chemistry that we have done so far in this year. After this video you should be able to take most anything off of the periodic table and know what kind of a compound it's going to make. So far up to this video we have talked about ionic bonds, and that's where the little atoms on the right side of the table come into contact with the big atoms on the left side. Because of the big size difference in these two atoms, the large atoms are going to lose their electrons and the small atoms are going to gain them. This is the strategy that the atoms use in order to get a full valence shell. When that happens, you get something that has an extra electron and something that's missing one, and we already know that that makes positive and negative, or ions. When they're right next to each other, negative ions attract positive ions, and they stick to each other exactly like magnets. On your paper, there's a spot for a quick write. Ionic bonds always happen between a metal and a nonmetal, or the fat kids and the little kids. Why can't it be between two nonmetals? Please pause this video and write that on your paper. If you're still watching, you have paused and you've written this down, and your answer should say something about how atoms can only steal if there is that size difference because of the electronegativity. If you had two nonmetals, they're both equally strong. A thief would have a hard time stealing from another thief because they're both strong. So it has to be a metal and a nonmetal in these types of bonds. So let's go into that question. Well, what if there are two nonmetals fighting over the same electrons? If you were to take, for example, two atoms of fluorine, they are both elements that want more electrons. That's why they were able to steal from the metals. But in this case, when they grab onto each other's electrons, they're not going to be able to have a winner and a loser. So in this case, just like the image on your screen, they're still going to fight over electrons, but they get into this like eternal tug of war where they've each got a hold on each other's electrons and they're not going to let go. This is another type of bonding. We call it covalent bonding because they're basically sharing each other's electrons in the outside ring. Take chlorine, for example. We draw the Lewis diagram for chlorine with 7 dots, since it's in the 7th column on the periodic table. And if you look at it in terms of like having little parking spaces, each chlorine has one space that has a missing electron. Well, if you push these two atoms next to each other, they're each going to try to grab each other's electron. And then what ends up happening is that each atom now has 8. So you can count this one. Counting the one that it's in a tug of war with, it has 8. And same with the one on the right. By overlapping their valence electrons and sharing those two electrons, as opposed to just stealing like they were in the ionic one, this is another way for atoms to get what they want, those 8 valence electrons. When we talk about Lewis dots, this is really the biggest reason why Lewis dots are a thing. What you're looking at on your screen, it might not look like Lewis dots, but it actually is another version of Lewis dots. Here's the thing. Every line that you see is a shared pair of electrons, and then we just ignore all the rest. So let's take oxygen from water. Oxygen, of course, has 6 valence electrons, so there's 2, 2, 1, 1. I've just rotated it a little bit so that it matches the picture above, but we've got all 4 sides. And then if you take hydrogen, which comes along and only wants one more, hydrogen's a nonmetal, they're going to get into a tug of war when hydrogen slips in, and these 2 electrons are going to get shared between the oxygen and hydrogen, and these 2 are going to get shared on the other side, and then everyone has what they want. Remember, hydrogen only wants 2 because of having 2 electrons in the very first ring on the Bohr diagram. Over here on the other side, take a look at this nitrogen. So you'll see that nitrogen has 3 lines coming off of it, and it's bonding to this carbon down below. Well, remember the Bohr diagram for a nitrogen, it has 5 dots, which basically means that it has 3 little parking spaces, 3 places to make bonding pairs. Well, when nitrogen bonds, it's going to bond in 3 different directions because of those pairs. We're going to skip the middle box on your page and go down to the bottom for just a second. For this check-in, if you understand the difference between ionic and covalent at this point, now is a good time to put it into words. So at the bottom of your page, how does the ionic strategy allow atoms to get what they want? And then the other box, how does the covalent strategy allow atoms to get what they want? Pause this video and fill that in now. If you're still watching the video, you have taken a moment to fill that in. Here's what I put for my answers, and if you need to steal or add anything from mine, that's the whole idea. So in ionic bonding, the one on the left, the electrons are stolen. What that does is it allows certain rings to be exposed, and then those are the full outer ones. And then if you're the stealer, it allows you to fill up your outer ring. But both atoms get what they want by moving an electron all the way over. On the covalent bonding, the valence shells are overlapped so that everyone can have a full outer ring, because both atoms are too strong to completely steal from the other. So to recap, ionic bonding is always between metals and nonmetals. And the only reason it can happen this way is because one is weak and one is strong, but they end up getting both what they want in the end. The cheat sheet is the periodic table for this. The columns will tell us what kind of an ion an atom is going to become if it gets stolen from, if it's a metal, or if it's going to be the stealer, if it's a nonmetal. And we can use these charges to figure out what the compounds are going to be simply by putting them together. With covalent bonding, this is when you take two nonmetals, and because they're both too strong for each other to completely steal, they're going to overlap their rings in order to share electrons. And we use Lewis dots for this to show these bond connections happening. So remember the little parking spot idea, where if you push the two atoms together and make the dots fill in so that everybody has what they want, this is how we figure out the compounds when we're doing covalent bonding. On the back side of your paper, there's a place to practice a few of these. We're going to do just a couple together. Please flip your paper over. So on the back side, we're going to start with aluminum and chlorine. The first thing that we need to decide is what kind of a bond, ionic or covalent. In order to figure that out, we have to figure out metals and nonmetals. So aluminum is a metal on the periodic table, and chlorine is a nonmetal. This should right away tell us that there's going to be some stealing that's going to take place, because chlorine is relatively small and it's going to steal from aluminum. So that's going to give us an ionic bond. When we're writing the formula for ionic bond, we don't use Lewis dots. Instead, we use the ion charges. So aluminum is going to make a 3+ charge. And that's because it's in column 3, and it's going to get 3 electrons stolen from it. And that's what's going to make it turn 3+. Chlorine, on the other hand, is in column 7, which means that it wants to steal just 1 more. Well, if aluminum has 3 electrons that it wants to give up, and chlorine only needs 1, that means we're going to need 3 chlorines to completely take away all those electrons. So these two elements together are going to make AlCl3. We're going to need 3 of those. The crossing over method is a good way to figure this out. If you take the number in the charge and you put it as the subscript for the other element, it tells you what compound you're going to make. So 1 aluminum and 3 chlorines makes aluminum chloride when you put these things together. Well, let's say, however, you have 2 nonmetals. Chlorine is a nonmetal. So if you were to take 2 atoms of chlorine and put them together, now they're going to get into a stealing relationship. So this is covalent. For that, we're going to do Lewis dot structures. So just like you saw in the main part of the video, if we have 2 chlorines that come together, each one of them has this extra parking spot. And when they see each other's electrons sticking off, they're both going to try to grab that electron as if they were metals. Like, they're going to try to steal. But because both of them are equally strong, what ends up happening is they get locked into a tug of war. And this bond happens because they won't let go of each other's electrons, and we get a compound that looks like this. So on your paper, you should draw those Lewis dot structures with 7 dots apiece. If you have different colors, this is a really good place to use it. I'll use X's and dots to show it. And you can count to make sure, as long as everybody has 8 around them. But that's a lot of dots. So we just show a line to make things a little bit simpler. Your assignment for the rest of this is to complete the remaining. Please reach out to me in class if you're struggling with any of these. Ready, go.